Okay, so simplifying radicals. So if we have the cube root of 54, we talked about this in the last video that we did, where if you look, so since it's the cube root, that means you want to look for what number times itself 3 times would give you this information, or would give you this. So I'm going to do it just like we were doing simplifying square roots back before Christmas break. So I'm going to take 54 and I'm going to write out the factors. So we know we have 54 divided by 2, well, that's 27. So 2 and 27. And I just took a number. Since I know 54 is even, I did 2. Then I'm going to take 27 and break it into its factors. 27 divided by, well, 27 is probably divisible by 3, so 3 and 9. 3 doesn't break down anymore. 9 reduces to 3 and 3. So these are our n's. Now, since it's the cube root, I need them to be in a set of 3. So I have to look for when the number multiplies times itself 3 times. So we have 3, 3, and 3. So the cube root of 3 times 3 times 3, well, 3 times 3 times 3 is 27. If we took the cube root of 27, the answer is 3. So 3 comes outside of the radical. And then since there's a 2 left inside, the 2 stays under the radical. So it'd be the cube root of 2. So that would be the answer. That would be that problem simplified. So you're looking for, I did the factor tree. I'm looking for what number times itself 3 times gives you 54. Well, 27 times 2 gives you 54, and 27 comes from 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So this would be our simplified answer. Okay. Now if I have the fourth root of x to the fourth and y to the ninth. Okay, I'm going to go ahead and write all of these out just so that we have it, so that you can see it. So we have the fourth root of x, 1, 2, 3, 4. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And since it's the fourth root, let me use a different color. Since it's the fourth root, I need to circle them in groups of 4. So this one up here, we had to circle it in groups of 3. This one has to be in groups of 4. So 1, 2, 3, 4. 1, 2, 3, 4. With a y that stays inside. So x is going to come out. Y squared, since there are 2 sets of y's. So it would actually be y times x on the outside. But since y times y is just y squared, I just wrote it as that. Okay, so then we have, and I'm going to write it in the proper order. So xy squared, the fourth root. Now all of the x's came out, all these y's and these y's, so all that's left is a y inside. And that is simplifying radicals. So we've done simplifying square roots before, where we just kept looking for things in groups of 2. These are something other than squared, so you're looking for, so this one's a fourth. Okay, that was example 2. Now let's do example 3, and these are, I'm doing one of each kind just so that you have one example of each kind that you'll see on the assignment. So the fifth root of 4 divided by 2, I'm going to do x to the 7th, y, and then x squared. So 4x to the 7th, y divided by 2x squared. Now, when you have them where there's a fraction or stuff underneath the radical, you need to simplify all of that first. So I'm going to take this information and simplify it just like we've been doing. This is why I was talking about yesterday that what we're doing now is a continuation of what we did last week. So 4 divided by 2 is 2. Now we have x to the 7th and x squared, so 7 minus 2 is 5, so I have x to the 5th. And then y, there's nothing to cancel with, so it would just be y. Okay, now we're doing the 5th root. So the 5th root means I'm looking for groups of 5. It has to be the same thing times itself 5 times. If it's anything less, it doesn't get to cancel. So now if you look, 2, you can't list out the factors of. 2 is nothing multiplies to get to. Then x to the 5th, so that's x, 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 that's 3, 4, 5. So there are 5 of them. So since this is 5, this is 5, and there's 5 of them, all of them will come out. So I'll be left with an x on the outside. And then y, it's the only one, so it's going to stay inside as well. So it would be x times the 5th root of 2y. So we don't actually write a multiplication sign there, or like the dot. We just know that when I pull it out, it's x times that information. Okay. Now that leads us to our next one, the next kind. So if we have the cube root of 5x times the cube root of 25x squared. So if you look at that, since they're both a cube root, you're able to just multiply the information that's inside. So we're going to write 1 cube root. So now all of this information, since there's a multiplication sign between them, we're going to take 5x and we're going to multiply by 25x squared. So then we have the cube root. 5 times 25 is 125. And then x times x squared, that would be x cubed, because that's 1, and then 2 more, that makes 3. Okay, since it is a cube root, we're looking for groups of 3, so I'm going to go over here and do my factor tree. So 125, well, we already know 5 and 25. And then 25 breaks into 5 and 5. So since there are 5 of them, since it's 5 times 5 times 5, they're going to move out. So I'll be left with the 5 on the outside. Then we have x cubed. So there are 3 of them. So they move out. And that would just be x. Now there's nothing left inside. 125 was where the cube root of 125 is 5. And then the cube root of x cubed, remember cube of x cubed, that and that cancel out and you're left with just x. We talked about that yesterday. So my answer is just 5x because nothing else is left inside of the radical. Okay, the next kind is if we have the square root of 6 times the cube root of 8 squared. So if we look at that, this is a square root because there's no number. Remember, if there's no number written, then it's automatically a squared, and then this is a cube root. Since they are not the same, we cannot combine those inside of there. So a square root and a cube root cannot be combined. But since there's a squared up here, don't distribute that squared and that squared. It's actually going to be square root of 6 times the cube root of 8 times the square root of 6 times the cube root of 8. So now this and this combine, so then it would be the square root of 6 times 6, and then the cube root of 8 times 8. So all I did was write these two under the same one and write these two under the same one. So 6 times 6 is 36. You could multiply that out and then try to reduce it, but if you look right here, since there are two of them together, that's like 6 squared, the square root and the squared would cancel, so that just becomes 6. Because if you look, 6 times 6 is 36, the square root of 36 is just 6. Since there's a set of two of them, and this is a square root, then the answer is 6. Now we have the cube root of 8 times 8. That one, since it's a cube root, you can't just say 8, since there would have to be 3 of them multiplying. So let's do 8 times 8, which is 64. And I'm going to go over here and do the factor tree. So we know it's 8 and 8. 4 and 2, 4 and 2. 4 times 4 is 2 times 2. 2 times 2. So we have 2, 2, 2, 2, 2, and 2. Remember, the 4s are not at the ends. So only the 2, the 2, the 2, those 2's are the ends. Okay, it's cube root, so I'm looking for groups of 3. So there's a group of 3, and there's a group of 3. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 2 comes out, 2 comes out. So it would be 2 times 2. So 6 times 2, and then I'm just going to finish simplifying it by doing 6 times 2 times 2. Well, 6 times 2 is 12, times 2 is 24. Okay. We have 2 more problems and then we're done. 6. So if we have 6 square root of 3 plus 2 square root of 3. So since these are adding, I just made that look like a plus or minus. So since those are adding, you have to make sure that this and this are the same. Just like if I had a 6x plus a 2x, I would have to make sure that they both have an x on them. If they don't, I can't combine it. So since these are exactly the same, it's like saying I have 6x plus 2x. So you're just going to add. So 6 plus 2 is 8. So it would be 8 square root of 3. And you just have to keep that on there just like it was. Now the difference in like this one up here, where we multiplied the information that was underneath, this one's addition. So we just add the two like numbers in front of the radical. Okay? Last kind. So then number 7. So if I have 6 cube root of 2 minus the cube root of 54. Now, these two, if you look, currently this and this are not the same. So in order to get them the same, one of them is probably going to reduce. Well, 2 can't reduce, so let's try the 54. So let's do 54. We might have already done 54. Oh yeah, we did right there. So don't make more work for yourself. If you find that I've already done the factor tree for one of them, then go ahead and write it out. But I'm just going to go ahead and do it again just for more practice. So 54 is an even number. So I'm going to divide it by 2. So 2 and 27. 27 breaks down into 3 and 9. 9 breaks down into 3 and 3. Now it's a cube root, so I'm looking for a group of 3. Or 3 of the same thing multiplying. So it would be 3 times 3 times 3 times 2. The 2 stays inside. the 3 comes out. So this would be rewritten as the cube root, or 3 cube root of 2. It's negative because of that negative right there. And then 6 cube root of 2. Now this and this are the same, so we're just going to do 6 minus 3. Well, 6 minus 3 is 3, so it'd be 3 cube root of 2. And that's it.